Okay, number 4. Figure below shows a wooden block being pulled by force T that incline at an angle of 30 degrees above the horizontal surface. Table show the magnitude of the forces acting on the block. Okay, so the pulling force here is 36 Newton, so this one is 36 Newton. Weight is 24 Newton. Normal reaction is 6. Friction 20. Okay, A. Calculate the magnitude of the horizontal component and vertical component of the pull T. Okay, so we want to calculate the horizontal component and the vertical component of the pull of this force T. Alright, so this is the object. Okay, the force that pull is in this direction. Okay, so this here is the x component. Here will be the y component. Alright, so we can draw a parallelogram here. Okay, this is fx for the horizontal component, this one fy for the vertical component. Okay, a parallelogram, we can draw a parallelogram. So here this is the 90 degree, this one is angle 30 degree. So here and here is the same. This one is fy, this one is fx. Alright, so we can get one triangle from here. Okay, we just need one, so we take this one with the angle 30 degree. And we can calculate the fx and fy. Fx is adjacent to the 30, so we can use cos. Cos 30 degree equals to fx over t. Okay, so it's given that t is 36, so fx, which is the horizontal component, will be 36 cos 30 degree. So that means this is equal to, okay, so we get 31.18, okay, Newton. So this is the horizontal component. Okay, this is the horizontal component. Okay, so okay, we answer here horizontal component. Horizontal component fx. Okay, vertical component. This one is vertical component is opposite of the 30 degree, so we can use sine. Okay, so this one is the vertical component. Okay, fy. So this one is same thing, 36 sine 30. So we get 18 Newton. Okay, so we get the horizontal component and the vertical component of the pulling force. Okay, of the puller. Alright. Okay, next B. Determine the magnitude and direction of the resultant force acting on the block. Okay, magnitude and direction of resultant force acting on the block. Okay, so for resultant force, there are two components of the resultant force. We have the horizontal component and we also have vertical component. Okay, so the horizontal component is this one. This is Fx. This is Fy. So that means the horizontal component is this Fx together with this Fr. Okay, the frictional force. Alright, so okay, horizontal resultant force. Okay, I just add it equal to equal to the Fx plus the Fr plus the friction plus negative of the friction. Okay, because the friction is in negative. Okay, so Fx is 31.18 plus the friction given is 20. Yeah, exactly 20. Okay, 20, exactly negative 20 Newton. And then we get horizontal resultant force. So it's 11.18 Newton. Okay. Okay. Next, the wait, okay, no problem. Okay, horizontal resultant force 11.18 positive. Okay. Wait, okay. So just the horizontal determine the measure of the resultant force. Okay, so that means beside this horizontal resultant force, we need to calculate another one, which is the vertical resultant force. Okay, vertical resultant force. Okay, vertical resultant force. Okay, I will put F also lah. Okay, which is Fy going upward, Fy plus, okay, plus the weight. Okay, the weight given is 24 Newton. Wait a minute. Oh, yeah. Okay, vertical resultant force, it will be Fy plus the reaction plus the weight, okay, plus the reaction plus the weight negative 24. Okay, like that. Okay, so we get this one Fy is 18 plus the reaction here is 6, okay, minus 24. So we get 0 lah. Okay, we get 0. Okay, 0 Newton. So this is very logical lah. Why 0? You see, because this object, this box is put on the table. Okay, put on the table. So the wooden block will not fly upward or sink into the table. Okay, because the downward force and the upward force all add together equals to 0. So that means the forces are equilibrium. Okay, the forces are balanced. So when they are balanced, okay, so when the forces are balanced, so the resultant force will be 0 and the wooden block will not experience acceleration. Okay, there will be no change in the motion of the wooden block up and down, okay, in the direction up or down, there will be no resultant force. Okay, so as what we can see here. Okay, again, you look at C, it says what is the acceleration of the block if its mass is 2.4 kilogram. So we look at the horizontal resultant force, it is not equal to 0. That means the force is not balanced. Resultant force not equal to 0. So this resultant force will be able to give the block an acceleration. So if you want to calculate the acceleration, we just use this horizontal resultant force. We don't have to use the vertical resultant force, just the horizontal resultant force. Okay, so C F equals to NA. Okay, so 11.18. Mass is okay, it's given that here that the mass is 2.4 kilogram. Okay, so we get, okay, it will be 4.658 meter per second per second. Okay. Okay, I repeat, what is free body diagram? Free body diagram is where a diagram that shows all of the forces that are acting on an object. Okay, so for example, this diagram, this is a free body diagram because it shows all the forces that act on the block. So only got two forces, weight and normal reaction. But weight and normal reaction, they are not perpendicular. Okay, not perpendicular. Okay, so sketch the component of the weight of the block parallel to the inclined plane and the component of the weight of the block perpendicular to the inclined plane. Okay, so Okay, component of weight. Okay, the question say sketch component of weight parallel to the inclined plane. Okay, so first we sketch the component of the weight. So the component of the weight will be one is because this is the weight, so one is like this. This is the x component, and another component is this direction. Okay, so this Fx and Fy, they are both the component forces of weight. Okay. Okay, so done lah. Okay, A is done. Okay, Fx, Fy. That is what they want us to sketch component of weight. Okay, we sketch component of weight. One parallel to the inclined plane, another one is the component of the weight. Okay, just ask us to sketch, so no need to do calculation yet. Okay, B, determine the resultant force acting on the block. Okay, if you want to find out the resultant force, then that means we have to look at the force from the horizontal component and also the vertical component separately and separately. Okay, so if you want to find out the resultant force, that means we have to calculate the resultant force of the horizontal component and also for the vertical component. Yeah, so first we look for the horizontal component first. Okay, horizontal component. So it will be okay. It says smooth inclined plane. That means no. That means no friction. Okay. So this horizontal component will be totally equal to uh, to the to the x component of the weight. Okay, so this would be okay. So we need to calculate the fx is how much lah. So this is 60 degree. Then over here is also 60 degree. Here 60, here 60. Okay. Then horizontal component. This is fx, and it would be weight times the sine 60 degree. Okay, so equal to the weight is 24 sine 60 and okay we get 20.78 Newton. Okay. Here we calculate the vertical component. The vertical component is the Fy plus the 12 plus the normal reaction. Okay, so this Fy is adjacent to the 60, so we use cos. Okay, so the weight is 24 cos 60 degree. Okay, plus 12. Wait, I forgot to put that this Fy is in the opposite direction, so negative. Okay, negative. Okay, we get 0. We get 0. So if we look back at the situation, then we can understand why it is 0, because this block is resting on the this block is on the surface. Okay, so along and it slide down the surface, so it is not moving into the surface or away from the surface. So that means the y component of the weight must be equal to the normal reaction. Okay, so we get 0. After that, C, calculate the acceleration of the block if the mass is 2.4 kilogram. So F equals to ma. So what are the forces that is acting on the block? The vertical component is already 0, so only left the horizontal component, which is 20.78. Okay, so this 20.78 Newton is actually the resultant force that is acting on the block. Okay, so this mass is 2.4. So what is the acceleration? And we get 8.658 meter per second Okay, the block will accelerate down the slope at the acceleration of 8.658 meter per second